What would it be like if Earth had two moons? Would date night be twice as romantic? It might sound crazy until you realize Saturn and Jupiter both have more than 80 moons each. Did Earth ever have a second moon? And even more mind-bending, does it already have a second moon now? More about that later. With our current situation of the Earth and the moon orbits around the Earth. Everyone knows that. Well, not exactly. Between two bodies, there is a single point around which they spin and balance gravitationally called the barycenter. And no, the barycenter wasn't named after some scientist named Barry. It comes from the ancient Greek root baris, which means heavy. In actual fact, the Earth orbits the moon as much as the moon orbits Earth. In this video clip, you can see the Earth-Moon system with that balance point inside of Earth's crust. Notice how both the Earth and the moon orbit around the spot marked with an X, which is the barycenter. There's also some gravitational influence from Jupiter and the Sun and many smaller objects, so the orbits are not perfect and vary over time. When you add a third body into the mix, things get dramatically more chaotic. Three closely related bodies make it a mathematical nightmare that is impossible to calculate precisely. Have a look at what happens with three bodies as they interact gravitationally in the short simulation. Collisions, gravitational destruction, ejections, supertides, and massive tectonic activity are just the worst scenarios. But there are more. Before we get to what would happen with a second moon, you should know there are a few ways scientists think moons form. First is accretion, and it's considered the most common. This is when a planet is forming into a planetary system. There may be leftover material that doesn't get incorporated into the planet. This material can come together due to gravity and form smaller objects, which in turn can come together to form moons. Next is capture. A moon may be formed elsewhere in the solar system and be captured by a planet's gravity. This can happen if the moon gets too close to the planet and is pulled in by its gravity. Third is giant impact theory. In some cases, a moon may form when a large object collides with a planet. The debris from the impact can come together and form a moon. This is thought to be how Earth's moon formed. Finally, there's fission theory, which is more speculative but suggests that an extremely fast-spinning planet or moon can be torn apart into smaller pieces by centrifugal force from the fast rotation. Now, let's look at what would happen if there was a second moon. First, a second moon would either amplify or cancel our tides. Canceling our tides might result in the death of most sea creatures that rely on the moving water to churn up food for them to eat. The disruption of the food chain could end with a complete collapse and a barren planet. If moon number 2 was at just half the distance of our current moon, it would result in 16 times higher tides, drowning cities like London, New York, and much of our coastal civilization. Great for surfers, but most everyone else would be suffering. In more extreme orbits, tides and tsunamis could reach a kilometer. Coastal living would be next to impossible, and the livable land area of the planet would shrink significantly. It's not just water that would be affected, however. Soil, ice, and rock heave and move, though not as visibly as liquid water. This could accelerate the breakup of permanent glaciers and ice caps. It would result in frequent earthquakes, and of course there would be more volcanic activity as the crust was flexed and bent by both moons' gravity. The moons might get into a resonance that caused them to collide. If they did it high enough, they would coalesce into a new bigger moon that would cast a red glow of molten rock down on Earth at night. If that happened, our system would achieve a new balance and very little debris would fall on Earth. If they met lower, they could very well disintegrate, resulting in a solid belt of rock falling to Earth and circling the equator, dividing oceans into north and south and killing everything here because of the environmental disruption. It is more likely that our original moon would increase its orbit, drifting further away from Earth as it is already doing, and the second moon might come closer, eventually crossing the Roush limit, causing our planet's tidal forces within to make it break up into chunks, thereby forming a ring around Earth. If people were still living on Earth at that point, the nights would be about to get seriously romantic, with a scintillating ring up in the sky backlit by the moon's glow. Of course, over time, Moon 1 and Earth's gravities will disturb that ring and lots of chunks will fall to Earth. Equatorially speaking, real estate values will probably go down, and maybe in the literal sense. People could go a few hundred feet beneath the surface to live to be safe from falling rocks. Along with all this, the gravitational drag of another moon would lengthen our days on Earth. Depending on if it was in the same orbital plane or not, the Earth's axis might tilt, giving us less seasonal change or much more. The presence of a second moon could also have implications for life on Earth, particularly for nocturnal animals that rely on the moon for navigation and for mating rituals. The gravitational pull of a second moon could potentially disrupt these behaviors. You may have encountered the words Lagrange points before. These are 5 pools of quasi-stability created by any 2 large mass objects. For example, the Sun and Earth pair have their set of Lagrange points, while on a smaller scale the Earth and Moon have their own respective set of Lagrange points. It is only quasi-stable because there are other objects, such as other planets, that pull on all objects, causing this point to be more of a region rather than an actual fixed location. Nevertheless, something placed at a Lagrange point will stay in place essentially forever, wandering within that region. This is important because things like the James Webb Space Telescope are placed in these Lagrange points so they stay put. If there was a second sizable moon, however, it would disrupt all those locations, and it's unlikely they would be stable enough to be used for anything. Earth had many moons. Long ago, Earth had many satellites. It was inevitable as the planet accreted mass to become what it is today. Once it had settled down, a new companion joined it, roughly the size of Mars. According to prevailing theory, they crashed, splattered, and the ejecta eventually cooled and formed the moon we know today. It's quite likely that it formed more than one satellite, and they eventually crashed and became bigger and bigger until, proportionally, we have this uniquely immense satellite. Most moons are about 1/30,000th of their planet's mass, but Earth's is 1/17th. This may be what made life on Earth possible in the first place. Our moon stirs the oceans so chemicals can mix, so food can rise, so carbon dioxide and oxygen can exchange. The moon stimulates tectonic action and provides a lot of nighttime light for predators to evolve in. Without it, or if we only had tiny moons like Phobos, 25 kilometers long, and Deimos, 12 kilometers long from Mars, there could very well be no life here. You may not have known, but actually even now, Earth has small visitor moons that come in and out of orbit, some for years and some that only stay for a few months. Wandering asteroids get hooked by Earth's gravity and become temporary moons. One study suggested that the Earth has at least one of these mini moons at any given time. These little ones don't affect us much, but they're there. For example, there's a small quasi-moon orbiting the Earth now called Mo'oleva that is only 50 meters across and is 40 to 100 times further away than our moon. One day we may consider capturing one of these mini-moons, especially if it is rich in minerals we need to build space cities, materials that are otherwise too heavy to bring up from Earth. These micro-moons may be just the gift we need to get our orbital space infrastructure underway without breaking the bank. Tell us what you think would happen if we add a second moon in the comments below, and let us know if you have any suggestions or feedback for us. We appreciate your input. Thanks for watching, and take a moment to check out this next video, which you might find intriguing.